Good morning, students. In the series of the lecture in the atomic structure or structure of the atom, I have explained photoelectric effect as well as hydrogen spectrum. After that, today the topic for the discussion is dual nature of matter and radiation. That is, dual nature of matter is explained by de-Broglie in 1924. De-Broglie suggested that in 1924 de-Broglie suggested that any material objects whenever in motion, any material objects whenever in motion shows dual nature, that is the wave and particle. Based on this, he established a relationship. He proved a relation between wavelengths and momentum of the moving object. As per the de-Broglie equation, the derived form is lambda is equal to h upon mv, or lambda is equal to h upon p. P is the momentum. H is, what is that? H is the Planck's constant, and P is, what is that? Momentum. So, prove de-Broglie equation. According to Planck's quantum theory, energy of electron is associated with wave. Thus, according to Planck's quantum theory, energy is directly proportional to the frequency, or energy is equal to h into nu. H is the Planck's constant, and nu is, what is that? Frequency. So here he explained the wave character of the electron. So that is, it is the equation 1. According to Einstein's equation, if electron is considered as particle nature, then according to according to Einstein's equation, E is equal to, what is that? mc square. It is the equation 2nd. From equation 1st and 2nd, we get E and E is cancelled out. H nu is equal to mc square, and we know that C equal to wavelength into frequency, or nu is equal to C over lambda. So equation 3rd becomes, equation 3rd is now H into C over lambda is equal to mc square. Square and C cancelled out. So H upon lambda is equal to mc, or lambda is equal to h upon mc. Here the problem is, this c is the velocity of the electromagnetic wave, but de-Broglie correlated the material wave with electromagnetic wave, but they differ in their velocity. So therefore, so far as material wave is concerned, we now change c into v. So for what wave? Material wave, c equal to v. Thus lambda is equal to h upon mv. M is the mass and v is the velocity, that is equal to the momentum. Here we have proved the de-Broglie equation. That means h is constant, so lambda is inversely proportional to momentum, and it's vice versa. That means greater the value of the wavelength, lesser the momentum, and it's vice versa. Therefore, one question arises that whether the de-Broglie equation is significant in our daily life or not. So significance, write down significance of de-Broglie's equation. So one thing is very clear, in day-to-day life we come across various bigger objects whose mass is quite large but wavelength is very, very small. I can see it is too small to observe. Therefore, this principle is insignificant in our daily life, but this principle is valid only for the microscopic particles like electron, proton, neutron, because their mass is very, very less, so wavelength is quite large. Therefore, if you see the car running on the road, cricket ball in the flight, and the cycling, whatever it is, these are the bigger particles, macroscopic particles, and their mass is very, very large, so wavelength is very, very small. So we can't calculate the wavelength of the heavier or the bigger body in day-to-day life. Thus, it is very clear, this principle, I mean de-Broglie's principle, this principle is insignificant in day-to-day life, because in our daily life, we come across various bigger objects whose mass is quite large and wavelength is very, very small. I mean too small to observe. Hence, it is insignificant in day-to-day life, but useful for what particle? Yes, microscopic particle like electrons, protons, neutrons, atoms, because of their mass is very, very small. Let us compare the wavelength of cricket ball and electrons. It is very simple. This is interesting area because of you will able to understand which wavelength you can calculate. So first of all, let v is the velocity of the cricket ball, 60 meter per second, and mass of the cricket ball is 100 gram. Let you change 0.1 kg. Lambda, apply the de-Broglie equation. What is that equation? Lambda is equal to h upon mv. So dear students, here, so just you put this, lambda is equal to upon mv. H is the Planck's constant. That value is, this is what, kg m2 s minus 1 or joule second divided by, see, mass is 60 meter per second and velocity is 60 meter per second and the mass is, what is that, 0.1 kg. So kg cancelled, meter cancelled, second cancelled. So this 0.1 is divided by 10, 6 cancel, approximately it is 1 into 10 की power minus 34 meter. So just to realize, this value is very small, 10 की power minus 34. Therefore, it is very impossible to calculate the wavelength of such a cricket ball whose mass we have already assumed 100 gram or 0.1 kg. And the velocity is common for, I think, electron also. See, this side take electron, lambda is equal to, again, h upon mv. So dear students, here, what the value of x? 6.626 into 34 minus kg m2 s minus 1, and what is the mass? We can't change the mass because you know the mass of the electron 9.11 into 10 की power minus 31 kg, and see, velocity is the same. I have assumed the same velocity, 60 meter per second. Therefore, here it is the 60 meter per second. This cancel, meter cancel, kg cancel. So you will get approximately these values, comes to be 10 की power minus 4 or 5. What is that, meter? So it is bigger than this minus 34. Therefore, this is significant here. Here we can calculate the wavelength of the macroscopic particle, but we can't calculate the wavelength of the cricket ball. In that way, we are in a position to prove that de-Broglie equation is insignificant in your daily life. After that, we will switch over to a very important area, that is Heisenberg's uncertainty principle. So write down the new topic, Heisenberg's uncertainty principle. Why it is used as uncertainty principle? Because of once you take a trajectory path, an electron is moving like this is the expected path of the electron, right? This is the expected path and it is the proton. Now once you see the position of the electron, provide the light with the help of the photon. So what will you observe? When the light strikes the path of the electron, that electron is such a lightest particle having mass is 1/1837 parts by mass of hydrogen, and light consists of energy. Once the light strikes the body of the very small particles, then this is the deflected path of the electron. So see here, it is a deflected path and it is the expected path like this. So I have explained the motion of the electron on the trajectory motion of the electron. In that way, it is impossible to calculate the position and the momentum, position and the velocity of the electron with high accuracy. That is what Heisenberg uncertainty. What is to be uncertain? Two things are too uncertain. One is the position and other is the momentum, velocity. Therefore, it is, according to this principle, it is impossible to calculate the position and yes, next one is, what is that? momentum of fast moving particles like electrons, protons and neutrons with high accuracy, or precisely, I mean simultaneously. Simultaneously it is not possible to get the exact position and momentum of fast moving particle like electron, proton, atoms and molecules, because of it is such a lightest particle. An electron is very dark, atom is very very dark and very very small. Once you provide the light, electrons get deflected and not possible to get these two simultaneously with high accuracy and precisely. Mathematically de-Broglie gave a mathematical formula, that is delta x into delta p is either equal to or greater than h upon 4 pi. This is the fixed quantity, it is the fixed numerical data. H, we are very much familiar with the H, no need to explain further. H is the Planck's constant, 6.626 into 10 to the power 34 joules second by, and then delta x. What is delta x? Tell me anybody. Delta x is uncertainty in position. This is uncertainty in position. And delta p, what is that? Uncertainty in, what is that? Momentum. Thus you enlarge this numerical data. Delta x into m into delta v is either equal to or greater than h upon 4 pi, or make it symmetry, m delta x into delta v is either equal to or greater than h upon 4 pi, because from the change the object, mass is going to be changed, so changing the velocity and delta x. That is why it is known as, so far as if you want to calculate the delta x, whenever you want to calculate, the numerical data will be m into delta v into 4 pi, or if you can calculate the momentum, that is the delta x, then sorry for interruption. Then if you want to calculate the velocity, then h upon, what is that, m into delta x into 4 pi, the way you can calculate this and this. Dear students, now question again arises, like de-Broglie equation, is it significant in your daily life? Absolutely not. Most probably it is due to, you can see in daily life we see the various bigger objects. For example, you see significance in daily life, like de-Broglie equation, it is insignificant in daily life, because in day-to-day life we again facing the bigger objects. Let you see one example. If a rat is running around the corner in dark room, once you throw the path of the rat and you provide the torch or the source of light, then I hope rat will not change their momentum or the position. We can observe the position and the running capacity of the rat. Just like cricket ball in the flight, we can imagine the angle of the cricket ball as well as the velocity and the position. The way it is very, it is not useful in day-to-day life, but useful again for microscopic objects, because not possible to calculate the position and velocity only for the microscopic objects. So one question is very important is, let me see whose principle is rejected when de-Broglie or Heisenberg concept came into the existence. So the concept of the orbit given by the Niels Bohr, proposed by the Niels Bohr, was outrightly rejected Reason behind is as per the de-Broglie, that it is wavelength and the momentum just like here, position and the velocity, but as per the Neil Bohr, what he said, fixed definite circular paths where electrons revolve is called orbit. But orbital is something different, because we can't say electron rotate in the move in the first path, second path and third path. So the concept of the orbit was outrightly rejected when de-Broglie and Heisenberg concept came into the existence.